Hi everyone, I'm Dr. Season. Welcome to our course, Electricity and Magnetism. Electricity plays an essential role in our lives, especially nowadays that most of our works and things that we use requires electrical energy, like electrical appliances and gadgets. In this technological age, there is a need to have an understanding of how the basics of electricity can be used in our day-to-day living.
Today, we're going to discuss Introduction to Electricity. Since its introduction in 2001, the iPod represents a triumph of application of electricity, magnetism, and optics. Several key components of these iProducts function by exploiting electrical fields. For example, the click wheel, the primary interface for controlling most iPod models, detects the presence and motion of users' fingers. By sensing changes the finger causes in the electrical field in the device. The LCD display, like those on cell phones and laptops. Computers creates images by using electric fields to selectively activate individual pixels. Electricity is not reserved for electronic devices. However, do you realize that as you watch and listen to this video presentation, the information sent to your brain and processed there also relies upon electrical charges and electrical signals. Electricity governs your life in ways you probably rarely think about. Even the properties of all matter that surrounds you, the air you breathe, the water you drink, the chair you sit in, are largely determined by electrical forces acting in and between atoms. From your newest electronic gizmo to the glue that holds matter together, electricity is inextricably woven into your life. So let's take a closer look at what electricity is. Electrostatics, or static electricity, is defined as the study of electricity at rest. This does not mean that electrons, the prime movers of electricity, are at rest. That carry the electrons that are usually fixed. Electrons are in constant motion in matter, and they affect the behavior of matter through electric charge. Static electricity is a usual phenomenon. The most common example of static electricity is lightning. Static electricity is responsible for the shock you receive when reaching for a metal doorknob after walking across a rug. In order to understand how electric charge moves from one atom to another, we need to know something about atoms. Everything known to man is made up of atoms and molecules. Atoms are the basic building blocks of ordinary matter. Atoms make up molecules, which in turn form the objects around you. Atoms are composed of particles called protons, electrons, and neutrons. Atoms have electrical charges inside them. The nucleus is found in the center of an atom. The protons, the carriers of the positive charges, and the neutrons, the charged particles, are in the nucleus. In the outer part of the atom are found the orbiting electrons, or the carrier of negative charges. Normally, atoms have zero net charge. They have equal number of electrons and protons and are considered neutral. But electrons do not always stay in the atoms. They can be removed by rubbing or friction. Since electrons are outside the nucleus of an atom, they can readily transfer if they acquire sufficient energy. If one or more electrons transfer from one atom, the atom becomes positive ion. Similarly, an atom with excess electrons becomes negative ion. When charges are separated, static electricity is produced as the electrons regain their former state of balance. Now let us proceed to the properties of an electric charge. Number 1. The smallest possible amount of electric charge that an object can have is 1.602 times 10 raised to negative 19 coulomb. There is no other particle can have less charge than this value. Number 2. The magnitude of the smallest possible positive charge is positive 1.602 times 10 raised to negative 19 coulomb, while the magnitude of the smallest possible negative charge is negative 1.602 times 10 raised to negative 19 coulomb. These values are actually equivalent. And lastly, like energy, charge is conserved. It cannot be created or destroyed, but it can only be transferred from one object to another. Now let us continue our discussion. For the methods of charging, number 1, conduction. Conduction is the transfer of electrons from a charged object to another object by direct contact. In conduction process, a body with one type of charge produces the same type of charge on a conductor. From the illustration, you can see that the contact of a charged object to a neutral object is charging by conduction. Another method for charging is induction. Induction is a method used to charge an object without actually touching the object to any other charged object. Even without physical contact, electrons will move in the conducting surface if we bring a charged object near a conducting surface. From a figure, we can see that a charged object can attract an uncharged object close to it due to electrostatic induction. If a charged object is placed near an uncharged object, there is no direct contact. Separation of charges can be induced on the surface of the uncharged object. The induced charge, which is the opposite that of the charged object, is then attracted to the charged object. Next is charging by polarization. There are no free electrons to transfer throughout the insulating material. When a charged rod is brought near an insulator, there is a rearrangement of the positions of charges within the atoms and molecules. This effect is known as polarization. During polarization, one side of the atom or molecule is induced to be more positive or negative than the opposite side. Example is a charged cone attracts an uncharged piece of paper because the force of attraction for the closer charge is greater than the force of repulsion for the farther charge. Now, can you give at least 3 examples of the application of conduction, induction, and polarization? Type your answers on the comment section of this FB page group. Thank you and keep safe.